morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering, Institute of Aeronautical Engineering. Today our topic is modification by admixtures. In physical and chemical admixtures, we are using some admixtures for modification is required in physical and chemical point of view for better ground improvement for the construction work. What are the properties which we are required for the better understanding and better results for the construction work, and what are the desired properties we are going to get for modifying the soil properties. For that modification, we are using some of the admixtures. So this comes under in this modification by admixtures. In these admixtures, for the modification, what are the desired properties are required for the construction work for this soil. So in this soil, we have to enhance the some of the properties adding these admixtures. So and different number of types of admixtures are available for their own enhancement and modification and replacement of the soil. What kind of replacement is required for the construction work? We are going to consider those type of admixture for better soil property or required soil property for that completion of the project. So for this, in this modification by admixture is a ground improvement technique that involves in addition of the chemical as well as physical admixtures to the soil for their enhancing its properties. This method is commonly used to stabilize and as well as improve the engineering performance of a soil for various construction projects. Coming to the principles. In these principles of soil modification by admixtures, chemical reactions as well as physical alteration. So, in this chemical reaction, admixtures often react chemically with the soil to alter its properties. For example, lime reacts with clay minerals to reduce plasticity and increase the strength of the soil. For getting better soil strength or required soil strength for the design of the particular element of the structure, so we have to enhance this strength parameter in clay minerals. So we have to lime, it is going to react with clay, it gives the reduce the plasticity. So that nature of the plasticity we are reducing by adding some of the admixture, it gives the increase in strength parameter. So like that, for that, which type of chemical gives the what kind of reaction for enhancing the soil property for the required construction element. So in this, cement hydration forms cementitious compounds that bind soil particles together, enhancing the stability as well as the load bearing capacity of the soil. The cement hydration forms these kind of various properties. So for adding different kind of admixtures, it gives the better performance of the soil stability. Coming to the physical alteration, some of the admixtures like flash, slag physically alter the soil structure. So filling voids and reducing permeability. So these kind of little physical alteration is also helpful for the better performance of the soil in different properties point of view. Coming to the fiber reinforcement, these kind of reinforced fibers, different fibers are available. Those are synthetic fibers, different fibers are steel fibers. So those kind of fibers for providing that gives the better reinforcement in terms of the strength, in terms of tensile, and it prevents the soil cracking. So these are the principles. Based on these principles, we are going to modified the soil by using the various admixtures. The one is chemical reactions and the next one is physical alteration. Coming to the types of admixtures, in this, the first one is already we understand in previous slide, that is lime. And next one is the cement, fly ash, slag, chemical stabilizers, fibers. These are all the some of the various types of the admixtures which are available for altering the soil property, for getting the desired result of the construction work. In that, various elements are involved in that. The one is lime. Quick lime and hydrated lime are used to treat clayey soils. For clayey soils, we have to understand this quick lime as well as the hydrated lime. This lime reduces the plasticity. Once the nature of the plasticity in the soil is going to reduce, it means it increases the strength and enhances the workability of the concrete or whatever it, whenever we are adding that soil. So once we are reducing the plasticity, it means it enhances the workable nature of those particular material. So which involves different kinds of materials. The combination of materials is nothing but the concrete. Like that, the lime reduces the plasticity nature and increases the strength as well as the enhances the workability. The reaction with soil moisture leads to pozzolanic reactions forming cementitious compounds. So based on this lime, we are going to understand are increasing and what are the not required parameter, enhancing or reducing are all involved in this admixture type lime. Coming to the cement, in cement n different number of admixtures are there for adding these. So it depends upon the natural admixtures and some artificial. So many are there for this cement. This ordinary Portland cement is widely used for the soil stabilization. So for soil stabilization, we are using this ordinary Portland cement. In this cement hydration forms calcium silicate hydrate CSH gel. So in this and calcium hydroxide also for bind soil particles and improve the strength. So whenever the region is there with unbind soil particles, this kind of OPC we are going to add in that. For that nature of the CSH gel and those calcium hydroxide which is going to bend the soil particles and also it leads to the improve the strength of the soil. The next one is fly ash. Coming to the fly ash, it is the byproduct of the coal. It is the byproduct of coal. So this fly ash is used to reduce plasticity and improve the strength. In these different types of classes are also available. Class C fly ash, like that different types of classes are available. Each different class has their own properties for and also the own kind of behavior. So in this, coming to the class C, fly ash has self-cementing properties, while class F requires an activator like lime or cement. So once we choose the class C fly ash, it means self-cementing properties is nothing but whenever some concrete is there, we are adding or we are replacing the cement with this fly ash using this class C type of fly ash. It is converted, there is a chance to, it leads to some sort of self-compacting concrete. For passing the, some tests are there for fresh properties and hardened tests are also there. Once those fresh tests we are conducting like V funnel, L box, J-ring. So in between the range, whatever the range is there for each and every property, it may lead to converted, call it as a self-compacting concrete. So this class C fly ash has such type of self-cementing properties. Coming to the, whenever we are using this class F requires an activator for getting these self-compacting, self-cementing properties. For getting self-cementing properties, we have to add some activator like cement or lime for class F fly ash. Coming to the slag, ground granulated blast furnace slag GGBS is used to improve the strength as well as durability properties. It reacts with activators like cement or lime to form cementitious compounds. Coming to the chemical stabilizers include agents like sodium silicate, calcium chloride, and polymers. They can improve soil properties through various mechanisms like ion exchange, precipitation, and binding. And coming to these chemical stabilizers, it is n different number of agents are included. It depends upon the where the particular soil is located, what kind of the changes we required. So based on that, we are going to include the agents. So different number of agents are available. So based on the which type of agent and it which type of mechanism it gives, whether it is ion exchange or binding, whatever it may be, it depends upon the which type of that stabilizer, what type of we are including the agent. Coming to the fibers, synthetic fibers, natural fibers are there. In these, they are mixed with soil to improve the tensile strength and reducing the cracking. So this tensile strength, we are getting the better strength. For that purpose, we are using these kind of synthetic fibers. So synthetic fibers and natural fibers are mixed with to soil to improve tensile strength and reduce cracking. Coming to the process of soil modification by admixtures. So in this soil investigation, selection of the admixture, which type of the mix design, whether it is low, high, medium, what are the various applications we are going to involve, and the compaction, curing, these are all the procedure for the which type of modification we done comes under the soil investigation. The first step is starting with the soil investigation. So this is the process of soil modification by admixtures. In that soil investigation, first we have to conduct the basic test to understand the which type of soil it is, what are the various properties are there, and suitability for the treatment. Coming to these admixtures, so first basic thing, we have to understand the which type of soil it is, what type of properties are there, and whether the treatment is suitable for this particular condition or not. And also internally we have to understand which type of construction is going on. So that is also one of the parameter for understanding the investigation. Then only how much strength is required for that soil, then only we are going to suggest or we are going to select better treatment, better suitable treatment. So coming to these common tests include plastic range, grain size distribution, compaction test. We are conducting some common tests. So including these particle size, grain size distribution, compaction test, and strength point of view, we are going to conduct some various common tests for understanding the soil condition and the soil properties. Now once we are going to understand which type of construction is going to, what type of construction and which type of element is going to construct in that particular soil region, after understanding all the soil properties, now we are move on to the selection of admixture. For this also we have to understand the what type of admixtures gives which kind of if we are adding some X admixtures, how it leads, which type of property is going to affect or which type of property is going to modify once adding this admixture in percentages also. So the how much dosage we are going to give to that is also the one of the parameter for understanding the soil modification by using these admixtures. In this, the selection of the admixture, coming to the selection of the admixture, first we have to choose the appropriate admixture. It depends upon the previous one. The previous step, soil investigation and as well as the project requirements. So in this, desired properties for the required project. So this is the very important step in selection of the admixture. So considering the factors, and also we have to consider the factors availability, cost and environmental impact also. So if you want to choose two same kind of reactions, we have two different types of admixtures. One is lime and other one is some X. So coming to this lime, it is not that much availability is very less, and usage of this lime is also going to affect the environmental point of view. So we have to consider all these parameters for choosing the admixture. For that, we have to understand availability and the cost and the environmental impact. The cost comes under both the ways, that is admixture cost as well as the project cost also. So for these are all the factors we have to, after that we are going to choose the which type of admixture it is. And after that we are going to move on to the next step, that is the mixed design. In this mixed design, we have to understand and determine the optimal quality and proportion of the admixture to mix it with the soil. For that, it depends upon the which type of mixed is required and what and we are going to determine the mixed design. Once the mixed design is done, we have to test some of the samples to establish the mixed design and assess that performance using some laboratory tests. After that, we are going to move to the application point of view. This admixture is spread on the soil surface and mixed using the required equipment like rotary tilers, the laboratory test to establish the mixed design, and we are going to assess the performance. Now move on to the application. We are going to apply the admixture which is going to spread on the soil surface and mix it with using equipment like rotary tilers or deep mixing tools. And batch mixing is also the one of the important parameter. In the soil and admixtures are mixed in controlled batches in a plant and then placed at the site. So after understanding the mixing, now we are moving to our next step, that is the compaction. So in this compaction, after mixing, the treated soil is compacted to achieve the desired density and strength. So for that we are using the standard compaction equipment like rollers or rammers is used. The next one is the curing. So allowing the treated soil to cure, which involves maintaining adequate moisture and temperature for chemical reaction to complete. So we have to give that particular time to complete the reactions, the chemical reactions. To curing periods can vary from few days to several days. It depends upon the which type of admixtures and what are the environmental conditions are there. These are all we are going to understand in this process. So first we are going to done the soil investigation. After that we are going to do the which type of selection of the admixture we are going to choose. After the choosing, we are move on to the optimal mixed design. After that we are going to apply. Next we are going to conduct the compaction and curing tests. So this is the process. Now we are going to work on which conditions we are going to apply. What are the uses of the soil modification by the admixtures? Road construction, foundation improvement, soil stabilization, land reclamation, abutment construction. These are all the n different number of applications are there for the soil modification. Coming to the road construction, stabilizing the subgrades and base layers to improve load bearing capacity and their durability. The next one is coming to the foundation improvement, enhancing the soil properties to support building foundations and reduce settlement. And the next one is soil stabilization, treating slopes to prevent erosion and landslide. And the embankment construction, using stabilized soil for constructing embankments for highways, railways and dams. Coming to the land reclamation, improving reclaimed land for construction purpose. These are the various applications which we are going to use for the soil modification by the admixtures. What are the limitations? For these also we have some limitations, that is soil type specificity and the environmental impact, curing time and application challenges, cost and availability. This effectiveness varies with soil type. It depends upon the which type of soil it is, whether it is sandy soil, clayey soil, granule soil. It depends. It depends upon the specific soil type. And some soils may not respond well to certain admixtures. So it depends. It depends upon the which type of soil it is and what kind of admixture it is and what is the desired property for these. What are the required property for these are the parameters, and these are the limitations are also. And also we have to consider soil type specificity is very, very important. It has its own limitation with some considerations. Coming to the environmental impact, this potential for leaching of chemicals into groundwater requires careful selection and use of admixtures. In this, we have to use these admixtures. It is not going to affect the environmental point of view also. We have to understand. This consideration is very, very important. And curing time is also requires adequate curing to achieve desired properties. So which can affect construction schedules. So we have to understand the curing time because of the how much it is depends upon them based on the construction schedules. After 1 week we are going to perform this construction schedule, and we are going to before and after the process is there, the step by step procedure is there for construction schedules. It is going to affect sometimes based on this curing time. So for that is also we have to understand, analyze where it is required and when we are going to complete, and the complete and any alters if must, we have to, the curing time is required for long time. It is going to affect the construction schedule, means alters also we have to consider. That is also one of the limitation in these admixtures. Using these admixture soil modifications. Now, application challenges. So, proper mixing and compaction techniques to ensure uniform treatment and effectiveness. So, it depends upon the culture and workman efficiency. So, sometimes man-made errors may happen. So, avoid those kind. Then only the required desired property we are getting effectively. This application challenges is also we have to consider in this modification by admixtures. And cost and availability. So admixtures in generally they are cost, and it depends the project is the project is affordable or not. For that, cost is also one of the important parameters. Sometimes the project allows how much the cost of the admixture is not a issue. In sometimes availability of the admixture is a point. Sometimes the admixtures may not available, it must required. That may affect again the construction schedule. So some of the admixtures can be expensive or not readily available in certain regions. So these are all the hurdles we have to consider for getting the desired properties, and we have to understand the soil we are going to modify by using the admixtures. These are all the parameters we have to kept in our mind. Then only we are moving next step for getting these using this admixture modification solution. So coming to the conclusion, this modification by admixtures it's a versatile and it is effective ground improvement technique that leverages chemical and physical admixtures to enhance all the properties. By understanding the principles, types and applications of the admixtures, engineers can effectively employ these techniques to address a wide range of soil challenges, ensuring the success and the durability of the construction works. These are the some of the web references we are going to understand in these. Thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.